All right, we are going to finish up section 7.1 in this video. We're still going to be talking about systems of linear equations in two variables, except now we're going to move into some word problems where maybe the numbers aren't going to be as that ugly, but the challenge in this video will be having to write your own systems based on what the problem is telling us. And so I've got 4 different problems for us to work today, and so let's get started. So beginning with number 1. On a certain hot summer day, 492 people were in the swimming pool. The daily prices are $1.50 for children and $2.50 for adults. The receipts for admission totaled $929. How many children and adults were at the pool that day? And so on a problem like this, they are describing a situation that you're going to have to write your own system with. Typically, what I do on these kinds of word problems to help people out is I like to label the 2 unknowns as my X and Y before I ever get started. That way, it'll be a little bit easier to explain the process. So just looking at this, they talk about children first. So I'm going to let, if I can spell, there we go, X be children, and I'm going to let Y be adults. And so as I read this problem, the first thing I notice that it says there were 492 people at the pool that day. But unfortunately, we don't know how many of each, children and adults, there were. So all I know at this point is that if I take the number of children and I add the number of adults, which will be X plus Y, I know when I am done with this problem, those have to add up to 492. The second thing they talk about is how much money the pool made that day. Well, according to this, they took each child that went in and charged them $1.50. So I'm going to write that as 1.5x because every child that was there was charged $1.50. And then I'm going to add to that how much they charged for adults, which was 2.5. And I'm going to multiply that by the number of adults, which right now is Y because we don't know what that is yet. But what I do know is in the end, when they added all the money up at the end of the day, it had to equal $929. And as you can see from here, your job is now to solve for X and Y, and that will be the number of adults and children that were at the pool that day. So similar to the last video, I'm going to do my addition method, and I either have to get rid of X or Y here. I'm going to choose to make X opposites. So to make the X values the exact number but opposite, I'm going to multiply everything in the first equation by negative 1.5. And so when I do that, I'm going to come over here to the right and do this. You're going to have negative 1.5x minus 1.5y, and then I'm going to need my calculator. So I'm going to do 492 times negative 1.5 in my calculator, and I got negative 738. And then my second equation, I'm going to leave alone. Just like the last video, the first step that I need to do is done because as I can now see, my x's are opposites, so they will cancel. If I put the y's together, negative 1.5 plus 2.5 is going to be just 1y or y. And then if I take negative 738 and add 929 to that, I'm going to get 191. And so what you just found is your y value. So this is the number of adults that were at the swimming pool that day. And since now I know the number of adults, it should be pretty easy to find the number of children. Because since there were 492 people there, and I know that 191 of them were adults, the number of children should equal the 492 total minus the 191 adults, which will give me 301 children at the swimming pool that day. And so it's very similar to what we did in the last video. The only challenge you will have here is having to take the word problem and write your own system before you begin solving. And so that is the first of 4 that I would like to work with you today. All right, let's do one with percentages. We haven't done that in a few videos now. So number 2 says the following. Janice invested a total of $5,900 at 2 separate banks. One bank pays simple interest at a rate of 12% per year, whereas the other pays simple interest at a rate of 7% per year. If Janice earned $568 in interest during a single year, how much did she have on deposit in each bank? So we're trying to figure out how much money Janice put in each bank. So similar to the last problem, I'm going to first label what are my X and Y. And so kind of just going in order here, I'm going to let X be the 12% bank, and I'm going to let Y be the 7% bank. Because we're trying to figure out how much money Janice put at each bank. Well, according to the problem, it says Janice put in a total of $5,900 between the 2 banks. So similar to the swimming pool problem, I'm going to take how much money she put in the first bank. I'm going to add how much money she put in the second bank, which are just X and Y. And I know when I am done, this has to equal $5,900. Now here comes your interest and your percentages. So in the X bank, we're gonna make 12% interest. Remember though that percentages, you have to move the decimal place to the left twice. So I'm not gonna write 12x, I'm gonna write 0.12x. Similarly, you've got your 7% bank. So if I move the decimal to the left twice, that would be 0.07y. And then here, if you add up the amount of interest that Janice is going to make, the problem tells us that it's going to equal $568. And your job, once again, is to solve for X and Y. How much money did she put into each account? And so what I'm going to do is keep it very similar. I'm going to get rid of X again because it's not really mattering because you got to find both anyways. So to make the X values opposite, I'm going to multiply everything by negative 0.12 in the first equation. And so when I do that, you will get negative 0.12x minus 0.12y, and then getting my calculator out, I'm going to do 5,900 times negative 0.12, and you should get negative 708 as your number. The second equation I'm not going to mess with, so let me bring everything over. And now that my x's are opposites of each other, I know that they're going to cancel, and I'm going to put everything else together. So if I take negative 0.12y and I add 0.07y, you should get negative 0.05y. And if I take negative 708 and I add to that 568, I will get negative 140. All right. I'm going to divide both sides by the decimal, which is negative 0.05. Those cancel. And once again, I'm going to get my calculator out, and I'm going to do negative 140 divided by negative 0.05, and I get a number of $2,800. Now remember, Y is the 7% bank, so this is how much money Janice put into the bank that's giving her 7% interest. Now I have to know how much she put in the 12% bank. But this, once again, the second number is usually a little bit easier because since I know, so we're going to do 12% bank here. I know that she had $5,900, and I already know that she put $2,800 in the 7% bank. So therefore, if I subtract these two, I'm going to get $3,100 as how much money Janice put into this 12% bank. And so very similar to the last problem we did, with the only difference being be careful about the percentages. Remember, move your decimal to the left twice before you plug it into your problem. All right. Going to number 3 of 4. This one says Ned, who owns the nut shop, sells peanuts for $3.25 per pound and sells cashews for $6 per pound. Ned wants to create a 58.5-pound barrel of mixed nuts and sell the mixture for $4 per pound. How many pounds of each should Ned use? All right, so once again, back to my similar technique here. I'm going to have to use an X and a Y here. And let's see, going in order. X comes first, so I'm going to call that peanuts because they mentioned that first. And then I'm going to let cashews be second. So that will be my Y. All right, so what does it say? It says Ned wants to create a 58.5-pound barrel of mixed nuts. Okay, well, that means Ned wants to take a certain number of peanuts and add a certain number of cashews. Don't know what those are yet. And when we add them together, they want that to equal 58.5. Then you get to the money part. So now we got to make sure all the money lines up. In order for this to work, however many peanuts you put in there, which is X, you've got to charge $3.25. So I would do 3.25X. And then for each pound of cashews, I have to put $6. So I'm going to call that 6Y. And then when I am all said and done, the final total, which is 58.5, needs to be multiplied by 4 because that will be my final weight. Now, when I do this, this is going to end up becoming X plus Y equals 58.5, and then 3.25X plus 6Y. And once again, just get your calculator out if you need to. That's what I'm doing. 58.5 times 4 is going to be 234. Now, I've got to solve for X and Y. So just like earlier, I got to get rid of one of the letters. Except this time, I think the Y is going to be easier to get rid of because of the decimals. So I'm actually going to take the first equation, and I'm going to multiply everything by -6 so that the Y's become opposites. So in the first equation, that will give me -6X minus 6Y, and then I'm going to do 58.5 times -6, which will give me -351. My second equation, I'm not going to mess with it all, so just bring it down. And just like I wanted to, the Y's are now opposite, so they go away, and I can work the rest of this problem. So I can take -6X and add 3.25X to that, and that's going to end up giving me -2.75X. And then I'm going to take -351, and I'm going to add to that 234, which will make this -117. All right, divide both sides by -2.75. So again, by all means, get your calculator out. And so X is going to equal -117 divided by -2.75, which gives me, I'm going to have to round my answer here. This is 42.55 pounds. And looking back at my problem, X is peanuts. So this is how many pounds of peanuts we need to use in this mixture. Now that I have how many pounds of peanuts I'm going to need, I now can solve for the cashews pretty easily because I know that my final mixture, so when we go to find cashews, I should say, I'm going to take my grand total mixture, which is 58.5, and I'm going to subtract how many peanuts I know have to go in this, which will be 42.55. And so doing some subtraction on my calculator real quick, I get an answer of 15.95 pounds, and that's how many pounds of cashews I'm going to need in this mixture. And so on this one, the numbers did not come out as nice as the last two problems, but you're starting to notice that the setup and the technique are very similar no matter which system word problem you're having to work. Just take your time and you can get these worked out. All right, and so I've got one more to do, and I figured I'd end with a fun one because I know most college kids like to eat pizza and have drinks. So we are going to do one of those problems involving a system. So for number 4 and the last problem for this video, if the total cost of 5 slices of pizza and 2 drinks is $16, and if the total cost of 6 slices of pizza and 3 drinks is $20.25, what is the cost of just 1 slice of pizza? So it's not even asking about the drinks, but we'll need that in order to solve this problem. All right, so once again, for the 4th time in a row, let's make sure our X and Y are the right things. It talks about pizza first, so I'll let that be X, and then drinks would be my Y. So reading the problem again, it says if you take 5 slices of pizza, which I'm going to call that 5X, and I add to that 2 drinks, if I add all this together, it should cost me $16. So I'm going to have 5X plus 2Y equals 16. Then it describes a different situation. It says if you've got 6 slices of pizza and 3 drinks, this should add up to $20.25. And so what it's asking you to do here, it's asking you only for what's the cost of 1 slice of pizza. Now, that's why I label things. Pizza is X. So in this problem, I don't want to get rid of X. I want to get rid of Y so that X is my final answer. And so what I need to do is I need to make the Y's be opposites of each other so that they go away. Now, this one's a little trickier because 2 and 3 don't go into each other. So I'm going to have to go up to the next number. So here's what I'm going to do. I know that 2 and 3 both can go into 6. So the first thing I'm going to do is I'm going to multiply the top equation by positive 3. All right. So let me show you what happens when you do that. You're going to have 15x plus 6y equals 48. Now on the bottom, the 3 is not going to cancel with that. So I need to turn the 3y into the opposite of 6, which would be negative 6. So I'm going to multiply everything in the second equation by negative 2. And that would be negative 12x minus 6y equals negative 40.5. So now I can add these together. My y's are opposite like I wanted, so they cancel. And so 15x minus 12x is going to be 3x. And then 48 minus 40.5 is going to be 7.5. And now all I've got to do is divide both sides by 3. And if I do 7.5 divided by 3, you end up getting $2.50, which remember, X is pizza, which is exactly what this problem was asking me to solve for. Based on this information, if I wanted to know what the cost of 1 slice of pizza is, I set up the system, I solved for my variable that represents pizza, which is X, and I found it to be $2.50 a piece. And so that is another good example of solving a word problem using a system of linear equations. That officially wraps up this video for section 7.1 and the word problems. This is also the end of the video sequence for college algebra here at Mississippi State University. So I hope you enjoyed the class and enjoyed the videos that I have here in Canvas and on my YouTube channel. By all means, take advantage of them. Go back and rewatch the lessons you need to. That officially wraps up the material for this course.